All right. Well, I'm very excited to be here. This is my second time here at NDC, Minnesota. Last time I was here, I was talking about TypeScript and React. And those technologies are going to be featured in this talk, but that is not what this talk is focused on. So with that, let me just briefly introduce myself. I'm Kamran Ayub. This is a photo of me in the south of France. Now, I'm a Minnesota native, so this is my natural habitat. But I would love for this to be my natural habitat. This is Provence, France. My wife and I, if you want to know a little bit more about me, my wife and I took a sabbatical about 4 years ago. And the original intention was that I would work remotely. Well, that didn't pan out. So instead, my company offered 6-month sabbatical, no work. So we lived in France for 6 months, and we traveled around. We went to Morocco and Amsterdam and the UK and Oslo and all sorts of other places. It was truly like a life-changing experience. If you have the opportunity to do a sabbatical, I suggest you do it. We did it before we had kids, and it was just like a transformative perspective change. So after that, my life had never been about work, but especially after that, it's not going to ever be about work. It's about just enjoying life. With that said, I do enjoy the work that I do. So I work for a local retailer, which will become very apparent. But on the side, I do Pluralsight courses. So I have 2 courses on Microsoft Azure, 1 course on RavenDB, if any of you use RavenDB. And then I also manage and run a website called Keep Track of My Games. So I'm a gamer. I was playing games before I started this presentation. I've always been a gamer. But I also have a very terrible memory. So if a game is coming out and there's a release date, I'm not going to remember when the game comes out. So I built an app that lets me track those release dates. It'll text me on my phone or email me when games are coming out. And now it's evolved into more of a video game organizational tool. So if you have a collection of video games, you can manage them through Keep Track of My Games. On that same line, my friend started a game engine here in Minneapolis, and it was written in TypeScript. This started about 6 years ago, and that's what those games I was just playing are built in. And so we do regular releases, and so I'm a core contributor on the Excalibur.js game engine. So check it out. We try to make it really easy to use, so if you have young kids and you want to get them into game development, it might be a gateway drug. Does anyone listen to the podcast Impact Theory? Okay. If you want to be more successful, like personally, and you want to grow personally, and you want to be more successful in your career, listen to that podcast. If you listen to that podcast every day, you are going to radiate happiness and bring that into everywhere that you go. Now, the host, Tom Bilyeu, talks about the idea of a personal narrative. This is the story that you tell yourself. And that story would sound something like, I'm the kind of person that. And so you should finish that sentence for yourself. And this requires some reflection on what statement would I say, the one statement that might define everything that I do. So for me, I'm the kind of person that seeks to learn and seeks to solve problems. Now originally, I thought that it might be loves to learn and loves to solve problems, but I changed it to seeks because that is really what I really like doing. Seeking out problems is just something that I enjoy doing. I'm not happy when I'm not solving problems. I'm happiest when I'm solving problems, whether they're business problems or technical problems or personal problems, that kind of stuff. Now, speaking of problems, this last project that I've been on at work for the past year had a lot of challenges, and there was a lot of business problem solving going on. And so that's what I'm here to speak about today. Now, I could just explain what our application does and how we architected it, but I need to show you the context of the problem domain that we're in. So I'm going to paint you a picture, but I'm a terrible artist, so rather than that, I'm just going to show you a picture. Now you can guess maybe what company I work for, but if you go to our website and you search for products, I'm very excited about Borderlands 3. Are there any gamers here in the audience? A little bit. So Borderlands 3, I'm very excited about. It's coming out in September. But when you view this product on our website, there is a bunch of data that gets displayed. So data like the product title, the price. But more than that, if you scroll down, there's a whole bunch of attributes around these items that we collect and we show to you. So model compatibility, okay, Borderlands is on PS4. It's also available on Xbox One. The street date when it goes live is September 13th, 2019. Use Keep Track of My Games to keep track of that. But it gets more complex. That's an example of a video game. Any Game of Thrones fans here? Spoiler alert, Dumbledore dies, just kidding. You can buy Game of Thrones shirts on our website. This is not an advertisement, but it's there if you want to. There are totally different attributes around a t-shirt. So I'm wearing a men's t-shirt. It's made of 100% cotton. It's below waist. These are not video game attributes. These are t-shirt attributes. And even more than that, each of these sizes are unique items. Like we have a small size, a medium size, a large size. These are all attributes that we have to keep track of. So the system that I work on is the system that manages that data. So how do we manage that kind of data? Well, we manage it very carefully. So as you can imagine, if I collect the wrong information and it gets displayed on our website, someone is going to get a very stern talking to. So our application helps protect against that. So one of the primary goals of our application is to make sure that users don't enter bad data. So it has a very strong data quality focus, and because of that, it has a very strong user experience focus. And we have dedicated UX designers on our line of business application. And that was pretty unique for me, and that was pretty fun. Now, I work at a big company, and a big company looks something like this when you're looking at systems diagrams. This is what comes up when you Google image search complex diagram. But if I think about the domain that I work in and the team that I work in, this is very similar to how our systems are laid out. We are grabbing data, we're aggregating data, we're smushing data together from all sorts of different systems. They're managed by different teams. And even though that we're the mastering system, where this is where the core item data is stored, we have to work with other teams and their data. So let me tell you a story that sets up the rest of this presentation. And like any good story, we start with once upon a time. So once upon a time, I joined this team. It was about 2 years ago. We had an application that managed this item data. And it had been live for about 6 or 7 months, and it was rolled out to a subset of users across the enterprise. Well, while I was there on that team, we discovered that there were a lot of challenges with this application. So some challenges that we had was that it was very hard to debug our UI because, as I'm going to show you, it has a very complex UI state machine when we're managing multiple items and data. It also has the issue of dynamic business rules. So if I'm editing, let's say, a set of Borderlands games, there could be different editions. So we have Borderlands 3, then we have Borderlands 3 Super Deluxe Edition, which is a real thing. You might have Borderlands 3 Digital Pre-Order Edition. Each of those has different product titles. And so if I'm managing them together, our UI has to make sure that it understands that there's differences between items while we're managing it. That brings up the idea of 2 editing modes. And this, I think, was a unique UX paradigm that I hadn't really seen before or come across before. But we have millions of items in our store and online that we sell. Can you imagine managing those items one at a time? No, it's unthinkable. So we have users that come in that can manage up to 200 items at a time. So they might be rolling out new t-shirts for Game of Thrones. And they might want to edit all 60 variations of that t-shirt all at once. And of course they would. We want to enable that. But that presents some unique challenges for our UI. So I'm going to get into some of these UX paradigms, and I'm going to show some examples of our UI, but they are not direct examples. So because I work for a big company, I can't share much of the code that I've written, but I can share the patterns and practices that we put into place and the high-level architecture of our application. So this is just my mandatory disclaimer. Have any of you heard of the term wicked problem? This is a wicked problem. I don't mean wicked in like, oh, that's wicked cool, although a lot of problems are cool to solve. No, I'm talking about software design is a wicked problem. What does that mean? When you build software, you have to build it once in order to understand what the problem is so that you can build it again to actually solve the problem. And I first heard of this term in the book Code Complete. If you have not read this book, it's fantastic. It's How to Design Quality Software by Steve McConnell. It's a really good book. But this was a wicked problem. We had to press reset on this application because it could not meet the demands that we needed for this product. So the application would fall over after you tried to manage more than 10 items at a time. So what turned out to be the problem was that we were hitting so many different APIs and doing so many API requests, and it was all happening inside the client-side browser, that as soon as you got beyond 10 items, we were issuing thousands of API requests to different systems across the enterprise. Well, the application fell over pretty quickly. In fact, it would just crash the page. So we had to hit reset. So this past year, we've been rewriting it in React and GraphQL and TypeScript. And that's what I'm going to talk about. The easiest way to show what this application looks like is to start from the user experience, because I think it'll make it very apparent what kind of challenges we ran into. So let me just bring this up here. This is an illustration of what our UI sort of looks like, and this is a very focused thing. Our UI is a little bit more sophisticated than this, but these are the core UX patterns of our app. So if I'm editing Borderlands 3, I'm going to have multiple attributes that I need to manage. So here's 3 attributes. We have product title, we have street date when the game is available in stores, and the genres of the game. And so we have 3 different controls here for 3 different attributes. We have a text box here, a date picker, and like a list control. So we need to, our UI needs to understand what the difference is between these different attributes and how to render them. But to make it a little bit more complicated, remember that I said we can manage multiple items at a time. So if I expand one of these attributes, I may actually be, I went a little bit too far. I may be editing multiple items at a time. And so here I have the three Borderlands games that I'm managing and the 3 editions, and they all have different product titles. So here at the summary level, we need to make sure that you can update en masse what the product title is if you have very similar values for that attribute, which we would for the street date. So all the games are going to come out at the same time, but their product titles differ. So now we have to keep track of both of these attributes in 2 different states, and we're going to have 3 items underneath it, and they're all going to be in different states. But even more than that, we have dynamic business rules. So maybe these items are in a workflow state. Of course, we're a big enterprise. Items go through workflows, and they might be in different states. And that means that different attributes might be in different states. Perhaps they're not editable at a certain point in time. So if the item is launched already on the website, maybe you can't edit street date, so it becomes read-only. But that's not all. We don't place any restrictions on the types of items you can bring into this UI. If I wanted to bring in a t-shirt and Borderlands 3 both at once, I could do that. And they both might be in different workflow states. So I might have this concept of mixed editability where perhaps this item 2 for this Borderlands edition is in a state where it's editable, whereas for the other attributes, none of them are editable. So we need to be able to handle these complex UI states. Perfect. So we had to go back to the drawing board because the way that this application was originally written, we were thinking too narrowly in terms of how we wanted to render our UI. And what I mean by that is thinking about item data as just a set of properties on an object. And this is probably where you would start, and this is how the application started. You have your object that represents your product, and you have these attributes as properties. So that's pretty reasonable. If I'm looking at a product, it might have a product title and a street date. And this presents a problem for the system that's going to manage this data. This doesn't tell me how I should render it, what rules are associated with it. or anything about its workflow state or anything like that. So this is a consumer way of thinking. This is how our website might think of an item when it needs to print stuff to the screen. It probably wants some sort of aggregated object like this with just the values to display. So we need more than that for our application. So if only there was a pattern that existed that could describe data. I wonder if someone has come up with a system like that. Oh, like a database schema. So we use databases day to day, and I'm sure many of you have used databases. And if you're using a relational database specifically, you probably have to define a schema. That schema describes how the database should treat your data. It has rules around it. Should it have, what's the max length of that data? What data type is it? Is it a varchar? Is it an nvarchar? Blah, blah, blah. So that gave us an idea. What if we took that same pattern that we all apply to databases without even thinking about it, and we apply that same concept to our UI? So that's what we did. So we turned it from having an object that just had simple properties to an object that had metadata around each of these different attributes that could describe to the UI and tell the UI how it should be rendered. So we described things like rules. Is it required? Is it read-only? Does it have a min length? Does it have a max length? What kind of data type is it? What are the actual values that get displayed? And not only that, what are the raw values and what are the human-friendly values? So think about genres. In the database, of course, we're going to store the genres in a row in a database, and they're going to be the raw values, 1, 2, first-person shooter, cooperative. When I display it in the UI, I need those friendly values. Do you think that the item mastering system stores those friendly names? Of course not. So we're in a big enterprise. There's another team that manages those friendly names. So that would be the taxonomy team or whatever. We need to go to their API, and we need to pass in those genre IDs to get the friendly names back. That's what our UI was doing, just from the browser. And you can imagine how, if I'm managing hundreds of items, and they have 3 genres each, and I'm managing 100 items, that's 300 requests that I have to do to go get the friendly names. And it wasn't optimized. If you got the same genre back, it's not caching it or anything like that, so it's just shooting off network requests. So we had to describe, we chose to describe our data like this. We start out with a similar construct where the object comes back and it has the different attributes of this item. But now we're expanding that definition a little bit. Now we can show some more information. If I'm someone who's editing this item data, and maybe I'm new to my job and I don't understand what this attribute is, maybe I need some help text. Maybe I need something that can describe what kind of information I can put in this field. So now we can have a friendly description. More than that, we can set up default rules that get set. So maybe product title by default is required. Maybe because it's a text field, it has a min length, it has a max length. Perhaps it's not read-only initially, right? Because its initial workflow state, everything might be editable. Then we move on to display hints for our UI. What kind of control should I render? Is it a single-line text? Is it a multi-line text? Because those are 2 different semantics. Is it a list type where I can select multiple values? Is it a list type where I can only select 1 value? Is it a drop-down? Is it a toggle? Is it a yes or a no? Is it a date? Is it a date picker? All that kind of stuff. Then we have the actual item values. So again, I'm managing my 3 different games. The first game, the regular Borderlands 3, there's nothing special about it. So we have the raw value, which is the text that gets put into the input. And then we have the human value. Do you think that there could be a difference between these 2? Yes. So in the database, we might be storing the raw value with like HTML entities unencoded or Unicode characters. But for the human value, when we render it onto our website, we might want to show those characters encoded or so that we don't get like these weird special characters that get displayed on screen. So even for text, there could be a difference between raw value and human value. And then let's say that we're editing that second game and it's in a different workflow state. Well, now I can set some override rules, and I can say, hey, guess what? You can't edit product title for this item. So when you're rendering it in the UI, don't render a text box, just render the raw value. We can do even more. Let me scroll down here. For a date is totally different than text, so it might have different rules. We might have a min date. It's probably reasonable to make the street date not in the past, right? But who owns that information? Does the UI own that logic? Not necessarily. What if it was a date that was the release date, and you had to go back and edit it because it was a game that was already released, but you're just adding it to the catalog? Well, we don't want to have a min date then because it could be in the past. So the server and the business rules are what determine what these rules get defaulted to. So for a date, it's the same deal. But now here's an example of the raw date that we're going to show, that we're going to store in the database. It's probably going to be an ISO 8601 formatted date. But when we bring it to the UI, we want to show a friendly date. And this gives us both options. The client doesn't have to care about formatting the date, but if it wanted to, it has the raw one. So if a user wanted to customize their date format, they could do that. And again, depending on the business rules, we can override for individual items what that looks like. So this is the concept of a schema-driven UI. This schema handles multiple concerns. So it handles all the rule logic. So it ships the default rules to the client so that the UI understands how to render something. It ships hints to the UI on how to render stuff. And it also handles both client-side and server-side validation. So these rules like requiredness or min length or max length, you can imagine that I can write some React code that makes sure that after the user enters some text that I render the right thing, or I have a character counter if there's a min length or a max length. What about other stuff like min date? So that's when the server comes into play and it says, hey, this is a video game. This attribute cannot be in the past. Therefore, I'm going to set the min date and send it down to the UI. It also handles semantics, and I'll get into more of this. But attributes are related to each other. If I have genres, and I might have another attribute called primary genre. So they have a relationship between each other because a primary genre should be a subset of the genres that are associated with that item. And remember that we're not just talking about one item, but multiple. So the UI has to make sure that it can manage relationships between attributes at different levels. So how do we actually build this thing? And this is probably what you're most interested in. I don't want to be prescriptive. So this talk is not about why you should only use React or why you should only use GraphQL or why you should use TypeScript. You can apply these patterns to any of the technology stacks that you use. We'll start with the front end because that's where we started with the UX. So in our previous system, there was no state management system to speak of on the UI. And you should be cringing right now because that's what we were doing when we were trying to debug this application. It was nigh impossible. As soon as the user started to do anything more complex than editing a single attribute, it was like impossible to step through and reproduce issues. And so we had tons and tons of state-related bugs. Well, in our new React UI, we're using Redux. You don't have to use Redux, but you should use some sort of state management system because, as you could probably see from that UX, you need something to manage that state. Then we have the client-side rule engine. So like I said, one of the goals for this application was to make sure that users enter quality data because as soon as bad data gets onto our website, that's when people start to get a little upset. So since we are the gateway for that item data, we need to make sure that we can give people the fastest feedback loop to make sure that they're entering the right data. So we have a client-side rule engine. Then we move on to the back end. This is what does all the heavy lifting for building that schema out. And we sort of divide it into two distinct steps. So first we need to resolve data, and then we need to build the schema. So what do I mean when I say resolve data? Well, if you were thinking that all the item data comes from a single database, the primary data source, you'd be mostly correct. Probably, I would say, 80% correct. The other 20% comes from external data sources across the enterprise. So we are the master data system for item data, but we are not the master system for different types of attributes that we may want to collect. because we are the vendor user-facing application. We actually collect data that we don't store, and we need to ship it to these master data systems. And so our GraphQL backend abstracts that entire process, and that schema abstracts that whole process, because I'm able to describe my schema in a generic way. The UI doesn't care where data goes or where it comes from. It's all a standardized contract. So what we learned early on was that we needed to have this caching layer. So remember that I said in order to show genres in the UI, I needed to go get what those friendly names were. Well, rather than do hundreds of API requests in real time to get that data, we actually cache a lot of that data because it doesn't change very often. And since we are using async-based infrastructure, message-based infrastructure, we can actually be notified when data changes, and we can update our cache. So in a little bit more detail, and like I said, I can't share code, but I can at least walk through the different steps that we do to resolve that data. So on the left side, we have our GraphQL query. And I'm going to go into a little bit more about the query language of GraphQL and why we think it's useful. But this should look familiar because this is the shape of the data that I just showed you in the response. So in GraphQL, you send it the fields that you want, and you get those fields back in the same order, in the same representation. So I'm going to get JSON back in this format. But what's kind of cool is I can say, I want a specific attribute. And then I want the values for only a specific amount of items. And you can see that I'm actually passing query arguments to this subfield. Try doing that in REST. I'm sure you could do that. But what's kind of cool about this is that it's a language feature of GraphQL. It's just supported out of the box. I can do this, and it allows a lot of customization. So now I've said I want to get genres, and I want to get it for these items. So first we run our typical authentication authorization process. Can you even hit our API? Are you allowed to even hit our API? Can we even get data for you? Okay. Then we come up with this default schema. What does this mean? So when I joined the team, what I found, and I'm sure you'll find this in many enterprises, is that no one understands the data that they work with. Even our product owner couldn't answer a lot of questions related to, hey, for product title, what's the max length? I don't know. We need to go check the code. The code in our mainframe system that was probably written in COBOL. We have to go down to that level to figure out what those rules are. So what we decided to do was, now that we had the schema contract, we could actually just statically describe all these attributes in one place. And so we chose Git. Why did we choose Git? So that our PO could submit PRs to that repository and just edit the rules. And we would just ingest those rules into our NoSQL database. That would actually be what gets shipped down to the UI. So as soon as you make a change to the default schema, that could be reflected in the UI in minutes. And we were running into problems where in order to roll out these new attributes, because we have hundreds of attributes, like I showed you, video games, t-shirts, they all have different attributes. And we have thousands of items and thousands and probably dozens of departments that have different attributes. We're rolling out like 100, 200, 300 attributes. It was taking months to do that. And we flipped it to taking minutes in order to do that. As long as it didn't require anything new in the schema, a different component. If it was a text field, we already had that built. You could roll out new attributes in minutes and hours versus months. So we have this default schema. This is what represents our baseline that we're going to ship. Then in GraphQL, you have this mapping layer. And it's two types of mapping. So in GraphQL, you have these things called resolvers. They're just functions. And you have a resolver for each one of these fields: ID, default rules, display, item ID, raw value, human value. The ones that are really interesting are the raw value and the human value. So those are going to have a little bit more work associated with them. When I'm at a resolver level in GraphQL, I can have access to these arguments. So I know exactly what attribute I'm trying to get, and I know what items I need to go get them for. So that might result in a database query. It might result in an API request, but I have to do that mapping. And so this is one of the more sophisticated parts of this process, is mapping what these IDs actually go to as the source of data. Now once I have it, I have loaded the raw data, probably from our database, and I've also loaded external data for human value because I need to go get the display values. Now we pass this to our schema engine. So we have all the data available to us. Now we run rules. So what I mean when I say we run rules is we have these default rules. These apply in most cases. And then we apply exception-based rules. So we might say for item 1, we have the genre first-person shooter. Its raw value is 2. So remember, this got populated from some cache. And then we decide whether or not we need to override anything. Is this item in a workflow state? Does the user have access to this attribute? We have multiple roles in our system. Not all of them can edit everything. Different roles can edit different things. In fact, if you're in a department, you might even have a business rule that says you can only edit items in your department for these attributes. So we get very, very granular in what we can do. Once we run those rules on the server, our business rules, we then poke and prod at the schema. And we change what the overrides are. And then we merge that back and return the final version of the schema. So if I need to override some rules, like I said, and if this workflow state said that this item is in state X, and now it becomes read-only. So it's no longer required, because if it was required in the UI, I might show a notification that says, hey, this is blank, please fill it in. But now I know that it's not required, so I'm not going to count it against the user for not filling it in. And besides, I'm going to change how I render it so that it's read-only. So rules like this get run, and they poke and prod at the schema. And we're just making small changes. So remember, we have that default schema that's on the left side. This comes straight from like Mongo, this whole part. And then for each of the values, we go fill them in, and then we just override one at a time what the different rules are. So there's a lot of challenges with a system like this. It took us a year to build. And so this kind of system is not easy to build. Some of the top challenges that we had were that business rules need almost all the data loaded to work with. So what you should do is make sure that you resolve all that data before you pass it to the schema engine so that it can run its business rules. Remember that in the query arguments I said I wanted genres. But what if genres required another attribute to load data? So you have to make sure that you understand the relationships and can load those. Human data, that display data, has to be cached. Otherwise, you're going to run into performance problems. So you have to introduce a caching layer. There's no way around this. It depends on perhaps your system architectures, but in our case, we have dozens of APIs that need that cache data. And not all attributes have the same performance profile. So what do I mean by that? Well, maybe primary genres, in order to fill in the values, comes from X API. And X API has an SLA, and they say we return stuff in 500 milliseconds or less. But then you have another set of attributes, like, I don't know, for a t-shirt it might be a color. Is it a black color or whatever? Fun fact, we have like thousands of colors, which is kind of ridiculous to me. But those come from a different API, and they have a different SLA. They might be, we have so much data, we can only return in about 2 seconds. So do I want to group fetching the genres and the colors together? Probably not. I probably want to split that out. So we introduced like a hierarchy of our data. And this is pretty common in the product space, but you can group like attributes together, and you probably want to group them based on the performance profile and where they're coming from. So this brings me to like why GraphQL? Why did we go with GraphQL? So the primary thing that I would say, what I like about GraphQL is that it's a specification. This means that we don't argue about as much stuff as we would argue with REST. And anyone who works at a big enterprise can tell you that not every API is designed the same. No matter how much you want to try, people have their own opinions about how they design APIs, and they might be using gets when they should use a post, or they should be using post when they should use a put. And my God, it's ridiculous, right? So just remove that argument from the equation. How many of you use Prettier? Prettier.js. Why do you use Prettier? So you don't have to fight. That's why you use GraphQL. So you don't have to fight. At least you can fight about things that matter, not things that don't matter. So this provides predictability. I know how to issue a query to GraphQL because it's well documented. It's a specification. I can only do certain things. That provides consistency. I don't care where the data is coming from. I don't care, in most cases, how it performs. I just care what data I want and how to query it, and that's all self-documenting. So that provides safety because GraphQL is statically typed. I'm a big fan of TypeScript, and that's what we wrote this application in. And having both TypeScript and GraphQL, that provides some awesome safety when you were dealing with APIs. More specifically, here's an example of the static typing. So in that data structure I showed you, we might describe part of it like this. In GraphQL, you declare your types. And it has a fairly simple type language. It's not as robust as TypeScript or C# or other statically typed languages, but it's fairly robust. And I can describe most things. The exclamation mark means it's required, can't be null. And even that is like a lifesaver. If I know that this API never returns null for this property, then I probably am safe not checking it. And if I'm using TypeScript, I can even make sure that that happens at compile time too. And there are tools that actually can translate this into TypeScript types for you. You don't have to keep them in sync. You can run it on an automated basis. So I can describe all the different rendering types in an enum. And then for queries, you can pass in arguments to queries. You can re-alias fields if you don't like the term description. Maybe on the client side you want to rename it to title. That's all features that GraphQL provides. And then at the subfield level, think of it almost like a subquery. You're just filtering these results. So when I want to get my items, I just pass in the item IDs that I want. I could get more sophisticated. I could do filtering. I could do skipping. I could do taking. I could do paging, that kind of thing. And then you can also use directives, and directives are pretty powerful. There's some built-in ones. In this example, I'm passing in hydrate, true or false. Hydrate means go and get the cached data from the caching layer for human values. So the client can decide whether or not they want to work in a more optimized fashion, where I don't result in extra latency getting these human values, or they do want to do that. So it's up to the client to decide. In addition, you can also do subqueries. So these are technically multiple resolvers that are being called in a single GraphQL query. And the client can determine how much stuff they want to get in a single request. So if you have a REST endpoint, usually the pattern is that one REST endpoint does one thing and returns one thing as a single responsibility. Well, you can still divide your GraphQL resolvers into single responsibilities. It's just the client can say, I want to get multiple things. That's pretty reasonable, right? So you can do that. Two other things that I really like. In GraphQL, versioning pretty much goes away. And that's a little simplistic to say that because you have database dependencies and other API dependencies. But in general, because you have this query language that is pretty robust where you can implement custom directives, what if you just implemented a directive that says, hey, if you're asking for max chars, perhaps use max length instead because we're deprecating it in January 2019. And in addition, since every single one of these fields has their own resolvers, that means that each one has a function, which means that you can track who's calling and requesting this data. So I could say, team A, team B, I see that you're requesting max chars in your GraphQL queries. Please switch it. Then once my metrics say that no one else is requesting max chars, I can deprecate it safely. So with GraphQL, at least on the front, you have one version. You don't need multiple versions. Subscriptions are something that are pretty awesome that we ironically don't take advantage of. But if I'm updating item data, let's say that I have 5 people updating the same set of items. If someone else comes in and makes an update, perhaps I want to notify them that their data changed. And GraphQL supports subscriptions out of the box using like a pub/sub mechanism and WebSockets. Depending on what you use, there are a lot of other benefits. So we're using Apollo server, which is a pretty popular GraphQL server. And they provide a lot of things out of the box. To do that caching layer that I said, it sounds fancy. All we did was configure the Apollo Redis caching provider. We give it the nodes that we wanted to go in Redis, and it just takes care of everything else. And of course, you can modify like the time to live and stuff like that. But you get the field timing and analytics. If you want to opt into the Apollo engine, it's a graphical interface for displaying the performance of your GraphQL queries. And you can see at an individual field level what the performance of those resolvers are. You don't have to do that. That's built using an extension, and you can just use that extension, the open source extension, and build out the UI yourself if you want to. That deprecated directive I showed you is an example of a custom directive. You could do authentication directives. You could do directives that change the shape of the data. And these are all documented things that you can do because the language specification lets you. And so it's a very extensible architecture. You can do middleware. We have logging middleware that logs errors and catches errors. We have timing middleware that we built that can time queries to external services so we know why a GraphQL query is taking a longer time, et cetera, et cetera. This is where I admit that you could totally use REST too. I have nothing necessarily against REST. I have an opinion. I really like GraphQL, but that's a subjective opinion. Your opinion might be that you really like REST and OData, and that's totally fine. Like I said, this pattern can be implemented with whatever technology you want to. So the React UI. The React UI takes care of dynamic rendering. It takes care of undoing and rolling back values. I'll show an example of that. And then it takes care of the relationship behaviors. And it takes care of editing multiple items at once. So for dynamic rendering, here we have our text box for product title, right? It's a single line text. But then if I have a read-only rule, then that component needs to morph and only just display the human value, not the raw value, the human value. For implementing other types of rules, like perhaps max length, if the UI component sees that max length is an applicable rule, I need to add the character counter. And if we're using material UI, this is just another flag that you could add to the component. So this is totally dynamic. As soon as I remove or set this to null, this goes away. So these components have to morph. Date pickers are the same way. So if it's a date, I need to show a date picker. We have specific component types that might do a date time. So this doesn't have a time component, but maybe you have an attribute that does have a time component. You can either use the same component, React component, use a different one. It doesn't really matter, but you can key off the schema to determine what that is. It gets a little bit more sophisticated with lists. So if I have a list of values for these attributes, maybe it's a multi-select, which means that I can select multiple values. And then that implies that I should be able to type ahead. Well, what happens when we type ahead? Well, we have this schema that we built, this entire infrastructure that is able to code attributes by ID. The UI knows exactly what attribute I'm trying to edit, and it can just pass in the ID of the attribute that we're editing and ask GraphQL to go and get the type ahead values. So if I start typing in act, I might issue a GraphQL query that goes and filters the options by act. And the implementation could be attribute specific. You could have an implementation that gets shared by 90% of the attributes, which is what we do in our case. But for very specific attributes, you might do some crazy kind of business logic. We do that too. And since you have all the information available, you can just do it in a generic way. So I just showed one level of customization, but in reality, our product has multiple levels of customization. So our schema is a little bit more complex than what I'm showing you. But we can do stuff like we can customize at the attribute level. That's that component type that I showed. But we can also group attributes together. So think about product dimensions, width, height, and depth. Those are 3 distinct attributes, but they should probably be displayed together. So we group them together. And I can actually customize the component that gets rendered for that group. So in my UI, I might be showing the text box for a single attribute, but for a group, I might show like a modal, or I might want to show some custom UI that does some cool stuff. And we can do that. We can even go one level up, and we can say for this entire data set, for hundreds of attributes, I want to have a customized experience. And we did that too. So the past 4 or 5 months, we wrote a custom editor for import-related attributes, like tariffs, collecting tariff information, or answering questions related to how we import products. I don't know, is this made of plant material? If it's made of plant material, what's the genus? What's the plant name? Like, there are thousands of questions that we ask vendors whenever they're inputting item data that gets imported. It's kind of nuts, but it's really cool. This schema allows us to do this customization at whatever level we want to. One of the primary challenges with the previous application, the previous iteration of this application, was that we would save changes as soon as the user tabbed out of the UI. So if I'm updating product title and I tab out of it, we would issue a save to the backend server. Well, that caused problems, as you can imagine, because again, we have these dynamic business rules. As soon as you save data, it might affect other data in the interface. So for our new UI, we allow the user to confirm what they want. So we actually collect a journal of changes. So using Redux, we can store different versions of the state. We can store a change log where we can just replay the changes if we need to. What this allows us to do is give the user that quick data entry experience. Because in the previous application, as soon as you tabbed out, we might have to lock fields because you couldn't edit other data while other data was saving. And it was just like, it was basically a nightmare. Now in our application, we can actually just collect all the changes people want to make. And because we have this schema that tells us exactly what the behavior is between these attributes, we can just do it all on the client side. This also gives us the benefit of doing a batched save, so we can collect all these changes together and send them to the server. So I do want to talk a little bit more about specifically these relationship semantics. So attributes are related to each other, or many of them are. So for this example, let's say that the user is editing product title. They make a change, so we have this little blue pending icon here that denotes that this thing is waiting to be saved. And let's say that for some odd reason, perhaps product title impacts genre. So the server is not going to know what the new rules are for this until the value gets saved. So we can just model that in our schema using basic like array of properties. Product title is dependent on genre or whatever. And so we can prevent updates to that. So this is what I'm talking about. We don't have to go back to the server to do this blocking mechanism. We can just encode that in our schema. That's what it's designed for. We can do more sophisticated things. I mentioned the ability to do like a primary of a list of values. So this one is a multi-select. This one is a single select. These values are whatever the user has typed in here. Now, do I want to go back to the server every single time the user needs to go add a value here and then have it show up here? No. So I want to encode that in my schema and say that primary genre is a hierarchical relationship to genres. And so the UI understands, okay, I should use those values as the type ahead values rather than going to the GraphQL server. We also have the idea of conditional relationships. What if I picked co-op as a genre for Borderlands because you can play with multiple players? How many players? For a first-person shooter, perhaps we don't care about that question, but perhaps for cooperative, we do care about that question. So this attribute only shows up if I've picked cooperative. So our UI needs to know that. So we encode conditional relationships with attributes. So as you can imagine, graph theory and math comes in handy when you're dealing with all these relationships. I'm not very good at either of those. We have other people on the team that are good at that. I focus more on the user experience and UI. For handling multiple items, we have to handle mixed edits, variedness, and I'll get into that, and payload size. These are some unique challenges. I showed you the example in the user experience of mixed edits. So if I bring in 4 items to my UI, they might be in different states where only one piece of data is editable. I need to be able to handle that scenario. Perhaps 2 of 4, all 4 of them are editable. We need to be able to handle that behavior. The other behavior that we need to handle is when I bring in 4 items that have unique values for that attribute. Like I showed you, if I'm managing all Borderlands games, product title is probably going to be different between them. Street date's going to be all the same. So what we say is that street date is not varied and product title is varied. Why is that important? Because one of the primary use cases of our application is for people to come into the app and just scrub the data and make sure that it looks okay. Remember, data quality is one of our primary concerns for this application. So we need to make sure that people can just scan the list of data and see like what varies and what doesn't. Because these people, that's what they do all day, is they look at this data and they have a very, they're very tuned in to like product title should never be varied amongst these items. Like it's kind of cool when you actually sit down with them and see how they work through this. So variedness was something important to calculate. Then we run into the issue of payload size. If I'm making 100 changes to 100 items, and I have 200 array entries that I need to submit back to the server, we need to do some deduplication. So on the client side, we try to optimize the payload that we send back to the server. So that brings me to, what about saving data itself? How does that actually work? Because I've talked about how we get data and how we display data, but like, for example, optimizing that payload, where does that payload go? So the payload might look something like this. You might be collecting changes in your UI, and you might say, okay, for these 3 items, 2 of them have one value, the other one has another value. Then for street date, they all have the same value. Okay, that's pretty reasonable. The user's just tabbing through the fields, entering data. We have to send that back up. So first of all, we optimize it. So you can see there's not 3 array entries here for 1 per item. So we try to optimize as much as possible. Like values get merged, and unlike values get split up. Then we need to send it to the server, and the server has to do some work. So what's kind of cool is that we can reuse almost all the same schema infrastructure for getting values while we're doing a save. So remember that I've encoded relationships, so I know the dependencies between attributes, so I can use some dependency math to figure out what other data I need to fetch before I can save this data. And then I need to compare the values and see, has the value even changed? Okay, don't save it. If the value has changed, okay, go save it. Then I run it through a validation routine, and this could be isolated to, inside our backend, but we also have APIs that validate other attributes. So we might go to another API, and we might send them the data that we're trying to change, and they'll tell us, yes, you can change it. No, you can't. Here's why. We need to report those errors back to the UI. Then for ones that are successful, we need to persist them, and then we need to publish those changes so other people around the enterprise know that we changed data. This makes our UI a little interesting because we need to support asynchronicity because we're going to send this payload up, and we're not sure when it's going to come back. But we don't want to block the user from continuing to make changes. So what we try and do is be optimistic. So we say, I'm editing, let's say, product title. It goes into a state where it's saving. And then once it's successful, it reports back with a success. If it's an error, it reports back with an error. But that doesn't block me editing other attributes unless there's a relationship that says that. But perhaps we don't want to do this because doing this implies to the user that they probably can't change it. But maybe it's safe to do that. Maybe we just want to collect any of the changes behind the scenes and ship them silently. So we could do something more akin to like Google Docs. Every single time that you're typing in a Google Doc, you don't see like an indicator necessarily that's in your face that's saying that it's saving stuff. It's like way up here at the top, and it's kind of silent about it. So we can just timestamp like when people are updating data. So there are several challenges with this. First, like I said, if you need data to save the data, then you have to understand those relationships, and luckily we have this schema that can tell us that. Then you need to determine transaction boundaries. If I'm updating 200 items, do I want to fail the entire request for all those 200 items if just one fails? Probably not. And so we work through how to split up item updates in transactions so that we can do that safely, but also allow partial success. So the UI needs to handle a partially successful save. Then we need to, like I said, handle async updates. We want to be as optimistic as possible, but sometimes we can't. So if something fails to update because they might have entered some data that fails a business validation, then we want to surface those exception-based corrections. We don't want to surprise the user. If they entered a value, perhaps they want to try it again if there was a network failure or something like that. So we just surface those exceptions, but otherwise it's mostly silent. So we want to build trust in our application. So when users enter data, they're trusting that that gets saved. And so we try to be optimistic where possible. So building this kind of system is not easy. We're using TypeScript. We're using GraphQL. That provides one level of safety. But we also have over 1,000 unit tests for this application, functional tests. Building this kind of app, what I like to do, like my personal philosophy, is that I want to make it easier for the next person to work on. And so we've tried to infuse the development team to make sure that that culture permeates like the way that we do our software design. We're designing the software because we've had multiple people roll in and roll off the team. People are onboarding, people have been there for 2 years. There's institutional knowledge for like how this software works. It's very important that when people are refactoring and making changes, that they're confident that their changes aren't breaking something existing. So we have regression suites and all sorts of stuff. So this is kind of the end of the presentation. That was pretty wicked, right? Both wicked in terms of that's kind of cool, what we built. But to be honest, it also is a wicked software problem because there are things that we would do differently. If we could do it again, what I would say is to do as I say and not as we did. Because I've lied to you a little bit in this presentation. I've presented the ideal state for what we would have done for this schema-driven architecture. But this is the real world, and the real world means that we make some mistakes. So the first mistake that we made was that we didn't use the same stack for the front end and the back end. So for the front end, we're using React, and GraphQL is considered the front end. And for the back end, we're using Java. So if we could use the same stack, it would give us a lot of benefits. Imagine being able to share a lot of the code that runs that schema on both the client and the server. But because it's Java and JavaScript, we can't really run that nicely. Perhaps in the future with WebAssembly, maybe we can. So we could get isomorphic rendering if we were using a Node.js stack on the back end too. We could share state. We could share code. More specifically, we could share that rule engine, the core part of our schema architecture. Imagine being able to run 90% of the rules on the client because there's no reason you can't. And then for the 10% that requires special authentication or business data, that gets run on the server. So we can reduce that feedback loop. So one of our primary goals was to make our user experience better so that users entered the right data. If we could share that rule engine, we could run it on the server and the client, we could get faster user feedback, and there'd be a lot less round trips to the server to get that feedback back to the user. We're also not fully utilizing GraphQL. So let me make a confession. The entire schema response that we get is actually through a REST API. Oh. So we're not taking advantage of directives. We're basically just using GraphQL as a proxy, and I would not recommend that. And that was not a decision that the current team made. That was a decision that was made before most of the new team members came on. So I'm not placing blame on anyone. It's just what it is. If we could utilize more robust queries like I showed with the sub-arguments. We could utilize more custom directives because we'd have control over that. And we could use more subscriptions with observables because like I said, we're not using subscriptions. That would be really cool. The other thing that would be kind of neat is we're using just a traditional relational database, and that's what was historically used, and so they just went with that. But if we could do it again and you ask the team, they would say that we should explore something more like Firebase or RavenDB or something that provided more real-time subscriptions to data. So with Firebase or RavenDB, you can actually get notified as soon as documents get updated. And that schema architecture that you just saw, that lends itself well to a document-based architecture. Whereas with a traditional relational database, there's query joins going on for information that we probably don't need to do that on. So we could get live updates. It would make our UI faster. Again, improving that feedback cycle. We get more async messaging so that we could shoot off messages. And perhaps we wouldn't use Redux in that case. I mean, why do that when we could maybe just store the user session in a real-time database and it's fast enough that we can just go back and forth to the database directly. So let me end by just mentioning where could you start. So if this sounded interesting and you're kind of interested in maybe exploring it for your business apps, the first thing that you should know is question, do you even need this? So this is more of a case study of this application that dealt with hundreds of data points that all had dynamic business rules that needed to be rendered differently, that needed to manage multiple items at a time. It's not likely that many apps are built this way, and so this was a unique solution that we built for our needs. If you think that you need something like this, you don't have to build it yourself. You could see if JSON schema will do this for you. So with JSON schema, it's a specification, so most of the decision making is taken out for you, and there are actually open source components and libraries that can take a JSON schema and render it right onto the screen. And one of those ones is built by Mozilla, and it's called React JSON Schema Form. That's not what we're using. We built the schema ourselves because we needed to do some unique things, so we rolled our own. So it's always that classic decision: do we build it ourselves, or do we buy? In this case, use an open source product. So I hope that was interesting. It's been a really great architecture that we found in our product. We just had a release the other day where we rolled out, I would say, 50 new attributes. And there was only 1 or 2 stories in the backlog for us, the front-end team, to implement, because 99% of the data structures that were needed with these new attributes had already been built. So my product owner is very happy with this architecture. We're very happy with this architecture. And perhaps it could make your lives easier too with your business apps. So thank you so much, and enjoy the rest of your NDC. I am here for questions, and I'm also going to bring up the speaker chat just in case. Aha, here we go. So the first question is, when did you go too far implementing a scheme that was more complexity or more work than needed, where a simpler, more naive solution would have been better? And how do we avoid going too far? Well, I think I sort of addressed it at the end, but I would start with simpler. And that's what we did. So we didn't just build this thing from scratch over a year. We actually spent about 2 sprints doing a proof of concept. So first we decided, was GraphQL the right fit? Would it work for our needs? Would TypeScript scale well to this kind of application? And so we spent about 4 sprints, all of us in one room, and we just worked together. The front end and the back end team were just working together, and we built out the proof of concept. So we could actually prove that A, it saved time, that B, the user experience was better. And so we brought it to our director, we brought it to our product owner, and that's when we actually got the green light to build this thing. So that's what I would say. Someone just says they like speaker chat. Do you guys in the audience have any questions? No? Pretty clear? That's awesome. I wish I could show code for it, but fortunately I just can't. But yeah, thanks, and have a good rest of your day.